Hello, today I'd like to talk to you about setting up the VSE sensor for the first time in the software version 2.7.1. So I'm going to assume you already have your static IP set up, and we're going to go right into the software. So we'll see multiple screens here. What I'm going to do is I'm going to clean up the data file screen a little bit so it looks like your first time in the software. Alright, so here we are, everything's been cleaned up. I'm going to go to parameters, then over to VSE, we're going to go new, and we're going to select VSE again. And we're going to make sure that this is a static address. And we're going to type in the IP address that we're looking for right now. If it's your first time, it should be the factory default 192.168.0.1. And the screen here, we can rename this if we'd like, or we can leave it as the IP address. In this case, I'm going to call it Octavis Video. And click Next. And we're going to mark it as Connect Immediately. Finished. Okay, and here we are back in the main screen. So on the left over here under Overview, we'll see that it says Octavis Video. And you'll see the box to the left of that is orange. That box is going to be orange when you are connected. If we double click there and it goes blank, we've just disconnected from the unit. We double click again and connected, and we can see parameters, history, settings, monitoring there. So let's get to work on setting up some objects for this unit to monitor. In this case, depending on which VSE you're using, you're going to select here. It doesn't change a whole lot in the menu, so I'm going to hit Next. N1 is referring to if you have a variable speed or a pulsed input, you can tell the unit what speed it's looking at so that it can use that speed in the equation for vibration. In this case, we're going to go not in use for both of the signals. Okay, and here we are at the next. Okay, so on this screen here, we're going to continue with diagnostic object. We're going to go up here, select new diagnostic object. In this case, you'll see you can have up to 4 sensors connected. For the examples we'll be doing, we'll only be using sensor 1 in this case for the setup. I'm actually going to name this, just for simplicity, unbalance. Now here, as we drop down the selection here, you see rolling element bearing. You'll see unbalance as an object option. You'll see ARMS, VRMS, and DRMS, which means acceleration, velocity, or displacement. You also see others at the end of that list, and that allows you to set up harmonics or specific frequencies besides that you want to take a look at. And we're going to do unbalance there. We're going to select Next. Here for the speed, because we have no speed input, we're going to go with constant speed. So you'll see N1 and N2 are both grayed out there for you, so they're not a selection. We're going to hit Next. And typically for these examples, I just use 6,000 RPMs to set up. Okay, so we've just set up one object. The next thing to do is to set up another object. So we're going to select new object there, go over here, we're going to select sensor 1 again. I'm going to type in RMS for us, and typically I usually just run with acceleration. So we'll select that here and hit next. Alright, so this is already set up for 10 to 1000 Hertz, which you'll see on the side there is an ISO standard, which says the majority of machines in the industry typically fail between 10 and 1000 Hertz. So we're going to select next here. We're going to just leave these large numbers in here, so 4000 milligauss and 8000 milligauss. Leave them in there. Not a big deal, because what we're going to really be doing when we're done here is taking a look at what the raw numbers are when you actually have this up and running in your application. So I usually set these high so it doesn't alarm before you know what it should be. Alright, so we've set up 2 objects so far, and the very last thing that we'll set up after this is going to be the signal input monitor. So we're going to click next. We're going to select new. Again, sensor 1. Okay, so effective value A is giving you average vibration, average acceleration vibration. Peak A is going to give you the highest peak across the scale that you're looking at. So it always gives you the highest number and not an average. And the effective value V, the last one here, is going to give you an average in velocity. So for our yellow alarm, let's toss in a number here, 2000. For our red, 4000. Right, next. Alright, so we have, as you'll see up here, our effective value A for acceleration, and we'll move on from there. This is the outputs. You can have them set normally closed or normally open. I typically recommend normally closed, as that allows you to evaluate whether you have a wire break or not, as well as if you have a failure. The next screen, typically you don't see most people using it. You can fill out your project information, the city, the address. Again, another screen here where you can put in a description. The last page here, you can actually print out what you just set up. And when we're done, we're just going to click finish there. So you'll see sensor 1, you'll see unbalance, RMS, our effective value are all listed here under the main parameter screen. Now up here you'll see write to VSE. This actually writes these changes that we've made to the unit. Until you hit the write button, there's nothing actually saved in the VSE just yet. Okay, so it's been written, and we'll see here on the main screen, you'll see unbalance, teach values, your yellow and red alarms, and a lot of information off to the side as well. So what are we actually basing these numbers off of? That's the next thing that I want to get to. So let's go up to history in the orange, and you'll see under sensor 1 we have unbalance, RMS, effective value. They're all checked off. In parentheses next to them it says 1 hour 0 minutes. And what that is saying is, looking at the vibration for an entire hour, it provides you the average vibration across that entire hour for the unbalance, the RMS, and the effective value acceleration in this case. So if you want to get more data points though, as I'm doing right now, I'm bumping this down to the minimum, which is you can get that value once every 5 minutes recorded into the history. Now you also see to the side here you can get some other variables that will be recorded, from average value to speed to a couple other more advanced options. Nothing I'd really worry about, just getting as much data to begin with would be my very first concern. So I'd come to history and I'd make all these 5 minutes. So as I play around with the amount of time, you'll see right below that we get all these numbers changing, and this actually represents the time that you can record history for. So depending on how many objects you have, you only have a set amount of memory, and that's going to change what you see down below. So it'll list the day, hour, and minutes before the memory starts to overwrite the oldest with the newest. So once I have that set up, we'll hit OK. We're out here in the parameter screen again.